Hi everyone, myself Dev Wankhede. I am MTech Artificial Intelligence student at IIT Guwahati. Currently, I am in my second year. In this video, I am going to give you the overall brief scenario about this project that I have made in my coursework. And after that, maybe I will give you a short demonstration regarding how does the things actually work. So what I have done in this project is I have built a hybrid mood-based music recommendation system that combines emotion detection with collaborative filtering and content-based filtering using KNN to give us a personalized suggestion based on our own mood. So talking about the contents, I will walk you through motivation, what motivated me to make this project, the data set that I have used, maybe certain pipelines or the end-to-end demonstration, along with the recommendation logic, what I have used for content-based filtering, what I have used for collaborative-based filtering, the result that I have got after everything, and the evaluation matrices maybe that I have used to check the performance of my models, and the final UI demonstration. So the problem statement is very simple. This music app only uses the past behavior and they ignore your current mood. And this leads to poor recommendation. So my objective was to detect the user mood, maybe based on his text, and then combine it with the collaborative filtering and audio-based content-based filtering and create a final hybrid recommender. So as we all know that music really impact how the way you feel, the way you're thinking, and then only looking at the history doesn't give us a better option for the current mood. So I wanted to build a system that understands exactly how you feel now, and after that I have applied certain NLP or natural language processing methods along with the recommendation logic, which eventually opened up a new direction in mood aware computing. So the tech stack that I have used, as you can see, I have used various tech stack like Streamlit for user interface, then the PyTorch and Transformer for emotion detection. Along with that, I have used scikit-learn for audio feature modeling, and you might have heard about scikit-learn, but I have used other libraries like scikit-surprise for SVD, which I have used to imbibe the collaborative filtering, and at last just the Panda for normal data handling or data frame. So talking about the data set, so this project uses two major data set. First is GoEmotion data set. So this GoEmotion dataset is the Reddit comments that we can find on the Reddit platform. There are around 58,000 Reddit comments which are labeled with 27 distinct emotion. And this dataset I have used to fine tune the model in order to detect the user emotion. And the next dataset that I have used is the Spotify audio features dataset. This dataset has various attributes or maybe features or columns you can say like valence, energy, or maybe loudness or tempo, and 27 different type of such features. And this feature help us the system to understand the mood of each song. So the model architecture is very simple. I have tried to keep it very concise and at the same time a little bit elaborative. So user types their mood and then the model predicts its emotion. To predict the emotion, I have used DistilBERT. This is a bird family's large language model. It is 40% smaller and 60% faster than the other bird families language models. After that, the collaborative filtering. For collaborative filtering, I have used the matrix factorization method, and in matrix factorization method, I have used SVD. Then for content-based filtering to check the audio feature, I have used KNN. And at the end, the mood-based scoring ranks the final list to make this overall system hybrid. So one by one, we will understand how the things work for each end. So for emotion detection, I have used DistilBERT as I said earlier. This is smaller and a faster version of bird family. What I did is I have simply fine-tuned this uh, bird on the GoEmotion dataset For emotion detection, overall it has 27 emotion, and once the fine tuning has been done, the model outputs the multiple emotion at once and works well for real time prediction. So when I'm saying that it's going to predict the multi emotion, then at a time there might be the chance that based on the user text it can predict happiness and joy also, and maybe sadness and sorrows also. So this is not a multi-class classification problem, but a multi-label classification problem. Next, collaborative filtering. So for collaborative filtering, I have used SVD. So SVD I have used from this scikit-surprise library, and what SVD actually does is it converts the user item rating matrix into the user factors and item factor matrix. So this thing have decomposed the overall matrix into two different submatrices, and this by doing this we can capture the hidden pattern like users like energetic song, or maybe users like fast tempo song, a loudness or jazz music, and finally it predicts the rating of unseen songs and generate the candidate recommendation. For content-based filtering, I have used KNN, or you better know it by K nearest neighbor. This is a very simple but very useful algorithm. What it does is it states that the particular data point is most likely to get influenced by the nearest neighbor data points. So in my case, each song has this 9 dimension audio feature, and I standardized this audio feature and then used KNN to find the song that sounds similar to the current target mood. So this is important when you have something like, we can say, a user has no history, or in recommendation system we prefer it as a cold start problem. So this KNN is very useful in a cold start problem when you don't have user history and you want to give something that will help him and that he will find it better and meaningful to use. So how does this overall system get a hybrid? So hybrid method works in these simple steps. Like first, definitely user will input his text, user will write his prompt or query. Based on his sentence, the user mood will be detected. And as I said, I have used the BERT to detect the mood. Once the mood is detected, then it will generate the 200 songs via collaborative filtering, because I have set the value of n equal to 200, that's why. And once it means generate 200 random song, then it compute the mood match score. So this mood match score is something like, for each emotion there will be certain list which will include the audio feature. So one of the possible case might be for joy, the valence can be 0.7 if you are ranging it from 0 to 1, and energy can be maybe 0.6. If the mood is sad, then maybe the scores will vary. So for each song it will generate this mood match score based on the audio features available on the Spotify dataset. And then I have used context also, but this is optional. Like if you can choose the user ID and again maybe the time. And at last, when everything is sum up, it will rank and recommend the songs based on the mood match score. So talking about the training setup, I have fine-tuned this DistilBERT for 5 epochs with early stopping. I have trained SVD on 1 million simulated interactions, and KNN was fitted after the scaling the audio features. And finally, all models were cached for faster interference in the Streamlit app. Talking about the evaluation matrices, to evaluate the emotion model, I used F1 score and some other parameters like ROC, AUC, and accuracy. And for collaborative filtering for SVD, I have used RMSE, or root mean square error, which was used to measure the prediction error. And talking about the result, so during inference, the user mood enter gets detected, their emotions are detected, and hybrid filtering retrieves and ranks the songs based on the mood match score that you can see. And the final playlist shows the mood match scores. This gives us far more personalized result than a single method. So we can see like on what basis actually our songs is getting rated. So now I will give you a short demonstration of my project to make you habitual with the platform. So right now I have opened my VS Code. Here you can see multiple things like data, the data set that I have used. Again, the fine-tuned GeoEmotion model. This is the BERT model which we're going to use for emotion detection or sentiment analysis. Apart from that, there is a notebook section which has IPYNB files in case you want to run this project on the collab. And these are the source file. I had tried to keep my project OOPS oriented or object oriented programming related, so that all the essential things will be carried out through a function. So this thing is beneficial if you don't want to do the same thing again and again and you want everything in a systematic order. Again, we have a readme file. This thing will contain all the essential overall brief elaboration of the project, overall view of the project. And then at last we have this requirement.txt. So in order to run this project, what you need to do is two things. First, you need to clone this folder, this repository from my GitHub to your local desktop, which is very easy. And after that, you have to run this requirement.txt. Why do we need this requirement.txt is that we need all these dependencies, modules, these packages in our local system, so that nothing gets conflicts with the system's own model. And this thing will create the virtual environment, and once you get that virtual environment you can activate it, and after that you can just simply select the terminal, maybe new terminal, and here you can run the project. So to run the project, only thing that you need to run is the app.py file. So we will write Streamlit. We had used Streamlit, that why we need to write Streamlit because it is the user interface package. Then run and app.py. Once you do this, then it will eventually take you to the new page on your maybe Firefox or Microsoft Edge. If you are running it for very first time, this thing will take few seconds based on the dependencies, your system power. Now we can see that a simple user interface has popped up, and here we can see three sections. So the first section is something where you need to write the current mood. It is by default has said that I am feeling happy and excited today, but you can write anything that you want, like I am so happy and grateful towards life. After that, I have kept the option to select the user ID for personalization. You can select any ID, and this thing is optional. You can select the timing based on the evening or workout. I have set only two as of now. Maybe we'll select evening, and now we will click on get recommendation tab. Once we click on this recommendation tab, the BERT will try to do the sentiment analysis or identify the user mood, which is user emotion detection, and based on which we can see that BERT has analyze the two sentiments that user is feeling based on the text provided, that is gratitude and joy, and based on which it will gives us the personalized recommendation system, recommendation playlist, and this playlist is based on the mood match score. So in the last section we can see this mood match score. The higher the mood match score, the first the recommendation about that song we're gonna get, and along with that mood match score we can see the valence and energy section, like how these things are aligned with the mood match score. and these are the top 10 songs list based on the user text that we can see. And yes, this is all about my project. Thank you.